Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you all will be doing good. It's your chemistry teacher from Bishar Model Girls High School 2, and in today's video explanation, we are going to discuss the Solvay process, which is one of the industrial procedure for the manufacturing of sodium carbonate and sodium bicarbonate. Let me first discuss what sodium carbonate and bicarbonate are and why they are important. Sodium carbonate is called the washing soda, and it is having a formula of Na2CO3 with 10H2O. It is a white crystalline solid. When we say crystalline solid, so it means it is a salt, and salts are usually prepared by the neutralization reaction in which an acid and bases are reacting together. So, in this process, we will discuss the neutralization reaction as well, and it is existing in the form of decahydrate. Deca means 10, and hydrate means water molecule. It means that 10 water molecules will be associated with each and every single crystal of the sodium carbonate, and these water molecules are called the water of crystallization. It is also given the name of soda ash because it can be extracted from the ashes of many plants, the sodium carbonate. Now, sodium carbonate is industrially and domestically both very much important. It is used for the laundry purpose. It can also be used in the softening of the water, hard water. Fine. So, in a previous chapter, in chapter number 15, we are familiar. We have discussed about the hardness of water, and the permanent hardness was removed by using the washing soda in one of the method of its removal. So, it can be used to remove the hardness of water in the form of carbonates. And secondly, it is important to produce the soap, glass, paper, and caustic soda, etc. And this procedure, baking soda, can also be manufactured. Now, the question arises: why just the Solvay process? There are a number of industrial methods which can be used to prepare the washing soda, but why just the Solvay process? The main focus on the industrialist is to use to follow that one procedures which they will face a little expense, and they can get more profit of that. So it is a cheap method, and it was first developed by Ernest Solvay in 1861. The raw material will be very much cheap, so it is called a cheaper process. And secondly, the raw materials will easily be available, and the most important one is that the raw materials can be regenerated. Regenerated means they can be reproduced in this procedure, and they can again be used in the process. Secondly, the it can give us the pure sodium carbonate and bicarbonate. Now look at the raw material. You can see ammonia, NH3. This is one of the a little bit expensive compound. Here it is used by the Haber process. The ammonia is produced by reacting the hydrogen and nitrogen of the atmosphere, while the rest of the raw materials are very much cheap and easily available. The brine solution is used. Brine solution is a concentrated solution of sodium chloride. When we use the word solution, it means that along with the NaCl, water will be there. And then, as a source of carbon dioxide, limestone is used. As we discussed, that it is the source of carbon dioxide, so it means that carbon dioxide basically is the raw material for the Solvay process. But as a source of this carbon dioxide, calcium carbonate or the limestone can be used. It is beneficial to know that it is also giving us the calcium oxide, which is a lime, which will be later on used in this procedure. Now, let me discuss the procedures first. Keep in your mind, dear students, the principle followed over here will be called the counter current principle. Counter current principle is that in which the liquid is dropped from the top, and the gas will be blown from the bottom. As the gases move upwards and the liquids, due to gravity, it goes downward, so there will be maximum reaction. So this reaction and this principle is followed here, which is called the counter current principle, in which the liquid portion of the compounds are added from the top, while the gaseous substance carbon dioxide is passed from the bottom. So let me start the discussion of the basic reaction which are involved in the Solvay process. The very first process is the manufacturing of the or the preparation of the ammoniacal brine solution. It is a physical mixing. Ammoniacal brine solution, as the name is indicating, it will be the mixing of ammonia the NaCl and the water. In this reaction, the water and ammonia will react together to form the ammonium hydroxide. As ammonium hydroxide is a base, so we got the first component of this procedure, which is the base. Then the second thing is the preparation of carbon dioxide and the slacked lime. Calcium carbonate is heated in the lime kiln to produce the carbon dioxide, and a side product, calcium oxide, will be obtained. This carbon dioxide will be passed in the Solvay tower or the main reaction chamber from the bottom, according to the principle of counter current, while the calcium oxide will be treated with water to form the slacked lime, which is called the calcium hydroxide, and it will be later on used for the recovery of the ammonia. Now, in the main chamber of this whole procedure is called the carbonation tower, or it is called the Solvay tower. In the first tower, we produced a ammonical brine solution. In the second tower, we produced the carbon dioxide. So these two are mixed in the reaction chamber. From the top, we will add the ammonical brine solution, and from the bottom, the carbon dioxide will be passed. Internally in this reaction, what will happen? The internally in this Solvay chamber, the reaction occurring will be the reaction between the ammonia and the water to produce the ammonium hydroxide. Then the carbon dioxide will be dissolved in water to form the carbonic acid. When both of these combine together, so we will get the ammonium bicarbonate, that is the NH4HCO3. But we do not need ammonia, we need the sodium bicarbonate and the sodium carbonate. So here comes the role of sodium chloride in the form of brine solution. There will be ion exchange. The NH4 will be replaced by the Na, and we will get NaHCO3, and as a side product NH4Cl will be obtained. Our main ingredient is the NaHCO3, so we will focus on that, but NH4Cl is having a role later on in the recovery of the ammonia. So this will be filtered fine. It is in the solution form, so it will be filtered, and sodium bicarbonate is filtered. Sodium carbonate is called the baking soda. If we need the baking soda, so the reaction will be stopped here, the procedure will be stopped here. But as we are going to produce the washing soda, so calcination is done. Calcination is the heating in the absence of oxygen or air. So this sodium bicarbonate is heated, and you can see in the reaction that sodium carbonate having a formula Na2CO3 along with the carbon dioxide and water are produced. Our main product is the sodium carbonate, while CO2 and H2O, as you should know, that these are the raw materials, so they will be retreated in the same procedure. The last one procedure is the recovery of the ammonia. So in the one of the step we got the NH4Cl, and in the starting step from the lime kiln we got the calcium hydroxide. So they both are treated together. In this reaction you can see that ammonia is formed. As a side product, calcium chloride is formed, and water will be formed in this reaction. The NH3 and the water, they are recirculated in the chambers, and CaCl2 is collected and will be used in any other sort of reaction. So this was the whole mechanism of the Solvay process. It is a simple procedure, and let me repeat the main points of this. Why it is followed? Because of its cheapness. Secondly, it will follow the principle of counter current. This is the flow sheet diagram of the all of the reactions occurring. You can see in the very first step we added the brine along with the ammonia to form a physical interaction, and physical solution will be formed, and it will be called the ammonical brine solution. In other of the, from the right hand side, if you can see, the calcium carbonate is heated and it is producing two products. The carbon dioxide is produced, and the calcium oxide, which is shown in the downwards, it is also produced. So main our raw material is the carbon dioxide. From one side, from the left side, we are adding the ammonical brine, and from the right side we are adding the carbon dioxide in the carbonation tower. In the carbonation tower, when all of these will react together, so we will get two main products. one is the sodium bicarbonate, and the other one is the ammonium chloride. Bicarbonate is further heated through calcination in the absence of air, so it will result in the formation of washing soda, and carbon dioxide will be released, and this carbon dioxide is recirculating, you can see through the arrow. And come towards the second portion, we are having ammonium chloride in the form of NH4Cl, and this side ammonium chloride, and from the other side the calcium hydroxide, which is obtained from the lime kiln calcium oxide when treated with water, so it will form the calcium hydroxide. They both will react in the ammonia recovery tower, and in the ammonia recovery tower NH3 will be formed, which is recirculated, and as a side product NaCaCl2 is formed. This is the whole flow sheet diagram of the Solvay process, and you should focus more on the connection of the arrows. In the industry, it looks like this. So let we start from the very first one, chamber in the extreme left side. There you can see that basically four chambers are involved. On the left side there is ammonia absorber. In the ammonia absorber, ammonia is there and brine is added. You can see the brine is added in it. Then it will be converted into the ammonical brine solution. This ammonical brine solution, after filtration, you can see, you can follow the arrows, and it will be flown from top ammonical brine solution. And in the chamber you can see some mushroom shaped structures. These are called the baffles. Baffles is to increase the surface area, means to say that when the liquid will be added in this and the carbon dioxide will be added from the bottom, so there will become maximum area for the reaction of ammonical brine solution with the carbon dioxide. Got it? So to make it the reaction to occur in a maximum level, this chamber is made. And on the other side, calcium carbonate, you can see in the lime kiln, it is heated to produce the carbon dioxide. And following the arrow, you can easily understand that it is added from the bottom. From this lime kiln, we also get the calcium oxide, which when treated with the water, so it will react to form a calcium hydroxide. And from the other side, the NaHCO3 is formed, which is sent through the for the ignition. Ignition means heating, or and here we are doing the calcination, and as a side product ammonium chloride will be added. And this ammonium chloride will go in the ammonia recovery tower. From that, you can see at the topmost reaction NH3 and a small amount of carbon dioxide again will be formed, and this will be regenerated and the process will be continued. So that was all related to the Solvay process for the production of sodium carbonate and sodium bicarbonate. I hope the topic will be clear to you all. Thank you so much.